Hello, this is the last video that we're going to be doing for the playlist, and this one is on incomplete dominance. In the video before, you saw codominance, which is where there are two alleles that are both dominant kind of over a recessive, or there are multiple alleles that are codominant over a recessive. So if we are looking at the difference between codominance and incomplete dominance, you can kind of see the difference in this picture on this slide here from ThoughtCo. Codominance would be that the red allele and the white allele are both codominant, and when they mix, they produce this new petal type that has both red and white available on it. Incomplete dominance works a little bit differently. Right? This is where we happen to have alleles that are incompletely dominant. One of them might actually be broken. Um, and not work nearly as well or get passed on nearly as often. And so, what that looks like is that if you had a red flower and a white flower that actually happen to mix, and the genes and the alleles within that flower were incompletely dominant as opposed to codominant, you would see a blend of that particular um, a blend of those particular alleles. And so the way that that would show up in a flower is as a pink petal. So if you were looking at the pink petal, you would not be able to tell which parts of it were pink, which parts of it were red, and which parts of it were white. So it would be a complete mix. All right, so if we were looking at how to do incomplete dominance problems, there's an image that's kind of over here to the right hand side, kind of shows you one of two ways that incomplete dominance actually works within different types of organisms. Most of the time, things like flowers, these are snapdragons. There are also some over here that kind of show you the same thing that are happening with roses, petunias, just about anything that you can get. Okay, so here in this particular mode of communicating, they are using the kind of capital letter C um, for um, complete. And so, what we are looking for here is the idea that you kind of use that as a base, much like I is used as a base in blood types. Okay, and so then we have capital R for the red snapdragon, capital W for the white snapdragon. And then you'll notice if those are produced in the P generation, that all of the offspring will be a blend, or will it be a pink snapdragon, which would be a blending of the red and the white. So all of those would be part of your first filial generation. So 100% genotype CRCW. All right. If you were to cross those to get the F2 generation, then what that would look like, right, is if we took this particular image and we took two heterozygotes and we crossed them, so basically two peak plants, then we would be generating 25% of the offspring in the F2 generation would be red, 50% of the offspring in the F2 generation would have the genotype CRCW and would produce pink flowers. And then the last 25% would have a genotype of CWCW and would produce a white flower, right? So that is a one way to actually write it. The other way that you will see incomplete dominance problems done is basically in the same way. Excuse me. It's just that you'll notice that the C's are gone. All right, so you're using capital R for red, capital W's for the white. When they cross in the F1 generation, you get all pink flowers, so all RWs. And then when you cross the F1 generation, the heterozygotes, which would be RW, so your pink flowers. In order to get your F2 generation, you will see that the outcome is the same. So basically, they're writing it the exact same, just without the C's as a base. Okay. Either way is acceptable. You will see them both ways on my answer key. Whichever one is easier for you to be able to do is fine with me, for when we happen to go over these on Friday. But that is kind of how you actually do and write the incomplete dominant problems. Thanks for stopping by.